Okay. So mixed integer programming means that some of the decision variables have to be integers, and some can be anything. Well, real numbers. I'm just taking notes. Anything else that we know? To be correct.
Just ask, is this like an exam question that's going to be on our exam, or have you drawn this up? It's way harder than it's going to be.
Yes.
The second one was the first one.
Yes. It's going to be one. No, I'm not saying this is going to be in the exam. It's from a book that used to come with Moses as a book of examples. Oh, you say language for an exam question. But the idea is better to do hard problems when you're studying, and then easy problems when the exam will be away. No, I think you should keep it there. So the exam questions are their own thing, past exams. They are actual examples of actual. This is an example of an actual, well, simplified, but sort of a more realistic problem. It's still probably simpler than you would do in the industry because probably kind of silly marginal constraints like Monday morning we have to do something else than the other day. General idea is this. Okay, so there's kind of well, one thing that this should make clear is that you have different types of generator. On one, you have different time periods on the other, and everything is going to be sort of like a two-dimensional matrix. For every time period and type of generator, you want to know how many are running in that particular time. You want to know how many you're switching on in that particular time because there's some cost associated with it. And you want to know how much they're actually making. There are basically these three things that you need to know. In any point in time, for any time period really, because it doesn't make sense to change it in the middle of the time period and switch to something else. So for the time periods are up here. For each of these periods of the day, you want to know how much of each type is running. That should give you somehow how many you've switched on each type beginning of that period comparing to the previous one. And also you want to know to what extent. So between this and that, how much of are they producing? General idea. Yeah. And, you want this information for each type and for each time period. So let's try to put it into some kind of mathematical language. So we have one set of indices for time periods, and we need another one for the type of generator. So give me a letter for the set of all generators. G. G. Okay. So this is the 4 types of generator. Okay. And then for each of the types, we know these things. So we can, I don't know. Available of G, that's the number available. Minimum, okay, so I'll use little m, big M for maximum. Fixed. Additional. Let's call it C for cost, and S for startup cost. So G is 1, 2, 3, 4. I'm just using letters so that I could write the constraints more concisely. And what perhaps I should have put here is that there's a certain demand in each period. Could be an exam question. It's not so hard. There's always
Is it going to be on optional question?
for extra marks. I can't remember what I put on the exam. I'll have to check.
Or just revise Philip's side of it and then
Okay, and the accounting.
yeah, forget yours.
That's a good idea. Moral of my questions are kind of chopped up and put pieces together. So you can't just do, for example, you can't just do a linear program. Not like there's one question on linear programming. A bit of linear programming, you know, the first post-optimality stuff, duality. Might be like a piece in one question and a piece in the second question. And third question. Part 2 of question 1 is something like this, and part 3. You can't get away, which is doing something. Okay, so this summarizes the data, I think. But okay, so what we need is some decision variables. Oh, I didn't send the register. I won't because I need it. Do it quickly so I can write on the side. It's completely unprepared because a student came just before the lecture. And we had to discuss an assignment, and then it completely threw me off. There's an extra question, there's a bonus question on the exam, who it was. Anyway, so decision variables. Okay, so like I said, we need a separate bunch of decision variables for each time period and for each generator type. So for each time period and generator type, we have the following 3 decision variables. Those 3 that we need. So I think we could really get away with just 2 for this, but it would be easier to write if we do 3, which are.
I give you my structure, right?
Hmm?
I give you what I've used to do, right? So I don't have to do, right?
Oh.
Like X system, X, well, XGT, GT is subscripts. The number of type G generators running in time period T.
Yeah, little x, for example. I don't know what you have. The number of type G generators. Is it legible? Yeah, it should be. Running in period T. Okay. Do you have anything else?
You can change that to this one, but the increase in output for type G generator at time T. It's not that subscript GT again. That happens possibly possibly output.
Increase in output. So like. Yeah. That's what you mean. Okay. We call it E for extra power. E for extra power. EGT. Above the what's it called? Minimum output. In output. So this is in megawatts, right? Looks like H.
And then I had S D for the number of 5G generators starting up in a period.
Number of 5G generators starting up in until. Do we use big S for something else? I'm using little S for that. That's okay. Even though it looks like it's not. Where's the undo button? Can't undo it. We have to register. I can use it. I forgot to bring that. I'll use that here. Have you got the objective as well? Or not yet? Or do people want a couple of minutes to think about the objective? Now we know everything. Yes. Who wants some time to think? No one. Okay. Everyone's too lazy to think.
Right.
Okay, go.
But I'm going to go with type 1, so you just have to write down the other ones.
Okay.
So for type 1, we've got 5,000 startup costs by
Oh. So that's SG.
you're going to want it in some of the
Yeah, we'll add that at the end.
so
Times?
SG times 5,000.
Okay, so that's big S is the 5,000 and little s is the duck. Okay.
Plus the fixed cost times by your
So that's the fixed of G times by the extra power. No, not the extra, by the X. Oh, GT it has to be. Is that what you were saying? You said something. No? Okay. Okay, that's kind of simple, yeah. And then last one is so that was CG and then okay, so for every type in each time period, this is the cost. Is it? I think it is. Oh, no, it's not. It's almost good. Yeah, this is good, but this was given per hour in the table. Table it says this is cost per hour. But each of the periods has a different length.
Right? But it's T not per hour, like each period inside. L subscript T. Well,
Yes, and that has to come into play here. And this is one. This was a fixed cost of running them per hour. This is a fixed cost of extra production per hour. So, and each of the time periods has a different length. Well, maybe not each, but they have different lengths. So we should really multiply it by the length of the period. Okay, so this times LT should do the job. I think we called it LT. Yes. You agree? So now these have to be added over all T's and all G's. And that's it. So T in T, G in G. They're all costs, so we probably don't want to maximize them. So minimize. So if we're taking it as part of the exam revision, don't forget to say whether you're maximizing or minimizing part of the equation. Yeah, because so strictly should add brackets because of the way some applies to the whole thing. Okay, now I'm kind of. Okay, that was easy. Now the constraints. I'm looking for any constraints now. Yeah, I don't know. I'll go from the left. So the first in the table. So the first thing it says is the number that are available. So that we shouldn't be using more than is available. Okay, so so the number we're using in any time period should not be more than G, and this applies to every generator type and every time period. Correct. Yes. You agree? Look puzzled. Okay. Any objections? Does anybody actually agree with it? Wrong. Okay, this is the number you have available. This is the number you're running. I don't think that.
Those are all T sort of capital T.
Yeah.
We say that should be-
Like in English, working.
So yeah. All separate. And they use the summation. Outright.
It's just the symbol, so you don't have to write them. Especially if I'm lazy. I'm just shaking. Okay. What else is there? Minimum output. Okay, so we're about to make sure that the minimum output is minimized. Okay. Whoa. Oh. Well, there's actually nothing with the minimum output in constraints. So minimum output is no constraint. Maximum output. You did want that one. You did want that one. That constraint. Yeah. Sorry, why is there no minimum output? Because of the way we set it up. Yes. Okay, so the thing is, what we said was E is just the amount above the minimum output. So we can't produce less than the minimum output. Yes. We'll have a constraint for demand which will work with the minimum output. Yeah. In a bit. So the maximum output is that. Okay, so you can't do more than the maximum minus the minimum. Right. So this is how much extra you can add. So that's per generator. So you can actually add, if you're running more than one generator, you can add this much for each of them. Okay? And that's the upper bound on, or the upper limit on the extra thing. What I'm going to write is I'll just put the non-negativity here, so I don't have to write it again whilst I'm at it. Okay, so that's the maximum, but I think that's what they have. What do they have? Yes. Demand. What did we call demand? DT. So that should be something. It is at least. Okay, and this is again for each. So each. Oh, that doesn't show. So something should be more than, well, at least the demand. And that is the total that we're generating. And the total that we're generating is the minimum plus the extra. So the minimum is MGT times how many of the generators are running. And the extra is the EGT. Yes?
It says that at any moment all working power generators must be able to cope with an increase by 20% of the demand forecast. Do not have the times DT by 1.2. Make sure you've got that extra stuff already working. Because it says the working power generator must be able to.
No. Okay, it's different, right? So this is what we're actually producing. And this has to be the demand. And there's another extra constraint, which you've rightly pointed out, which is that if we needed to start producing something without switching anything on, we would have to go up by 20%. Should be able to go up by 20% without switching anything. So that's enough. Okay. So I'll do it after this one's finished. This one's not finished yet. No. So this EGT is extra for all the generators in that time period, not per one. And if you had to times it, then you'd be 2. Not because it's weird, but because it wouldn't be linear anymore. So linear means you never, you have decision variable times some number constant, just given some later. The one times the decision variable, decision variable times number. But you can't times 2 decision variables. That kills linearity. So if you do that in a linear programming formulation, then that's it. Okay. So since we're doing linear integer programming, never ever multiply to decision value. Not in the objective, not in the constraint. It's very different. That gives you some quadratic programming. So you can take second powers and you can take products of 2 decision values. So that's very different. There was a bit of that in decision mass when we were doing data location or something. That was my new objective. Square roots and well, now let's stick to them. So you can't do XG times. That's the only way of designing total. Okay. It's a good point, thank you. Oh dear, time. Okay, so this is not finished because this has to be added over all the generator types for each. 20%. Libby said. Indeed, 1.2 times dt. But now this is not what we're actually producing has to be 20% above, but the maximum capacity of what we have running. Okay, so that's going to be that's the maximum capacity that we have. And you have to add them over all the generator types. Okay, does that make sense? Okay. Does it make sense to everybody else? Okay. So what we're producing has to cover demand. What we can produce without switching anything on is to cover 1.2.
It's bigger and maximum than that.
Yes.
Yeah.
And so what we're adding as extra, it has to be between times how many. Okay. Anything else? Yes, there is. I think there is one last thing. Is that we have to make sure that we can't get away with not switching anything, but increasing the number of generators that are running. Because so far there is no constraint that would prevent all the, what do we call them? All the little s's from being 0. And moving with the x's as we want. Right. So we need something. So okay, so how many we're adding? This is xgt minus xgt minus 1. So this is the number we have to start. Is it? G is the type of generator. X is the number of generators. You use that by yourself. Okay, so if in the previous time period we were running this many, now we're running this many, this is how many we have to start. Okay, this could be negative. In that case, we don't want to be, we don't want this number started to be negative, because when we're switching things off, we're not, the cost doesn't go away. So what we want is, constraint you put in is SGT is greater than or equal to this. So this is the starting. And this should be for each generate type and for each time period except for the first time period, because in the first time period we don't have any xg0. So there should be an extra constraint that really just does xg1 should be xg1 minus xg maximum. 7, that's the last time period in the day. Make sure that at midnight we're switching enough to cover the first time period from midnight to 6 compared to what was running from 10 p.m. to okay? HG. And finally, we want that for each generator and time period, SGT is this, and integer, and X
GT is integer. That should be it.
Sorry, we run out of time. No problem. Any questions? Okay, so no questions. Enjoy the homework. There is a lot in the handout which is about logical conditions, and that's kind of applicable to the homework problem. So if you get stuck on that, you can try to look up some hints.